Thanks for coming along to the next part of the Stormwater Fundamental series. This is a series we started this year looking at a range of different topics. So far, we've completed 8 of these sessions, and today we're up to the 9th one, looking at stormwater pollution in the real world, with a few more coming up in the rest of this year, and then already plans in motion to do something like this next year with a range of other speakers and a range of other topics. If you want to look towards watching the webinars that have happened already or look to register for the upcoming ones, you can do that on our website at oceanprotect.com.au/webinars, or you can sign up for our newsletter where you can kind of keep up to date with everything that's going on. Also, just before we get into things, just a little announcement. Ocean Protect and Derwent Estuary Program are doing a Tasmanian Stormwater Symposium in November. If anyone in Hobart or Tasmania is interested in coming along, we will be sharing more details soon, but you can register and find some more details via that QR code. Otherwise, we will be talking a bit more about this in the coming months, but that will be November 20th. And before we get into talking about pollution and stormwater, just a conflict of interest declaration here. Fotos, Brad and I all work for Ocean Protect, which is a company that supplies, installs and maintains stormwater assets that is removing pollution from stormwater. So just putting this here for kind of transparency's sake, but that's who we are. And for people not familiar with who Ocean Protect is, that's what we do. Before we get started, just some reminders. If you do have questions for us, please put them in the Q&A panel and we'll get to them at the end. It makes it a bit easier to chuck them there than in the comment section. Then the slides and recordings will be made available at oceanprotect.com.au/webinars. That will be up there as soon as we can get it. And then also, if you're looking to get a request for a CPD form, please email inquiries@oceanprotect.com.au. And so just for the people not super familiar with Ocean Protect, we have installed over 65,000 assets in Australia. If these assets were being maintained properly, it's estimated that these would be capturing over 9,800 kilograms of pollution per day. And since the start of Ocean Protect over 20 years ago, would have captured about 19.5 million kilograms of pollution to date. And so getting into the talk for today, we're going to be kind of breaking this up into the different asset types. So starting off with gully pit inserts, then looking at a few different types, just to kind of show the types of pollution being captured in these different types of assets. And so we're going to start off with gully pit inserts. And for people not familiar with that, or people hear about it but don't know what it looks like, the diagram on the screen right now shows the kind of process and what they can look like. There's a whole bunch of these in the market. However, the one on the screen is the Ocean Guard that Ocean Protect sells. And basically, dirty water will enter into the asset and then the pollution will be captured there with kind of the treated water leaving that asset. And so in the real world, this is kind of what they can look like. They'll be in drains, in car parks, and the sides of roads. So in areas with lots of traffic and people. And so when we get to actually looking down them, once they've captured pollution, there's a whole range of types of pollutants that can be found, with them really going to vary depending on the land use and the catchment, and even the season can really play a factor in the amount and types of pollution being found. For example, this was from a commercial site, and you can see a lot of plastics and coffee cups and cans and food packaging with a bit of dirt and organics here as well. But the types of pollution you find within these assets and in stormwater in general is going to vary from the different types of assets. But the amount of rainfall can carry different amount of pollutants into here. The frequency of maintenance will lead to difference in the presence of it. But basically, the idea of today's webinar is to really just show you how dirty, polluted, and yucky and yuck that stormwater pollution can be. This site again is still that commercial site, so there is a lot of those kind of big plastic pollutants, but then it can vary to more organic ones, depending if it's a more vegetated area, depending on what people are doing. And here there's some cigarettes, plastic bottle, and a range of other things. But I think an important thing to highlight here is also something that can play a factor in the types of pollutants found in stormwater is things happening in the world, whether it's a health pandemic leading to an increase in mass being found in stormwater pollution and in these assets, or maybe a ban in plastic straws or plastic bags, and everything can lead to a change over time. So with installing assets like this, there needs to be thought put towards the change and variability in pollution over time, as new laws and new events can really impact and play a factor in that, what's present in stormwater. And so to really help kind of provide some data around this, Ocean Protect did a study in 2019 over a 5-month period in Western Sydney, looking at 8 gully pit inserts for a kind of a large urban road catchment. And within that, we found there were 850 bits of plastic, which included a whole bunch of cigarettes, plastic drink lids, cans, plastic cups, and plastic straws, and a lot of sediment, 130 kilograms of sediment. So you can see that kind of imagery on screen right now. And what this really shows is that there is a lot of pollution in stormwater. It is something that needs to be treated. These assets need to be maintained for this pollution not to enter into our waterways. And I might hand it over to Fotos now to talk through some other assets and pollutants.
Yeah, thanks very much, Daniel. It's a pleasure being here. Look, as Daniel mentioned earlier, the whole purpose of today's webinar is to give you guys a visual representation of what it is that we find in the field. A lot of you may not necessarily have the ability to do a full confined space entry. So the products that we're looking at now are the ones that are located underground. And hopefully this gives you guys a real indication of what it is that we find in the field. We know that the primary function of a stormwater treatment asset is to capture and retain pollution, and that's exactly what they do. You know, there's hundreds of thousands of these systems installed across Australia. It would go from, and you can flick through some of these slides if you like while we're discussing the actual specification engineer. So in this particular case, you're looking at a brand new system, a construction site. You've got the gross pollutant trap there upstream of a detention tank, and that's what you would look in a brand new status. But what typically will happen is water will enter into the GPT. There'll be some sort of vortex motion, and that screen design will allow for some sort of self-cleaning. All those floatable pollutants that you can see on the top make their way down and into that sump zone. So there's a few photos here that we can go into that kind of show you, I guess, the condition. And keep in mind, you're just looking at the surface level. So that's just the floatable pollutant portion. There's also pollution that's captured in the midsection of that gross pollutant trap, which is neutrally buoyant, and then also the sediment that makes its way down into the sump zone, which typically has some sort of particulates or heavy metals that are attached to that sediment. So you're really just getting a glimpse here of what we see every day. Our maintenance crews are out there conducting periodic inspections and periodic maintenance on these systems, and without that ongoing maintenance, it's really going to have a detrimental effect to the downstream waterways. As Daniel mentioned, data is key. And so I think there was an analysis or a 3-year study conducted on approximately 1,000 GPTs. And you can see there on the pie chart, there's a bit of a breakup in terms of the litter versus organics and sediment. But, close to 1,700 cubes was removed in a 3-year period, and that's just 1,000 GPTs. We're talking about hundreds of thousands of these things. So again, we understand that local government authorities are the key drivers here. Their level of enforcement and their policy is going to go a long way to get these systems back up to a compliant status. And I think we move into the next technology, which is the radial media cartridge. It's a little bit different in terms of its functionality, and I think we might have a video that illustrates that. But there you go, looking at a brand new system that's just been installed in a detention tank. Obviously, the filter cartridge has a engineered media that's highly absorbent. It captures all the pollutants and contaminants. So this next slide gives you an idea of runoff enters via an inlet, or the pollution that's captured via that rushes through the actual filter media, makes its way through an under drain manifold, and kind of builds up that driving head to allow this center float or flotation device to pop open, and the treated water can run through. And then you can see the self-cleaning mechanism also. But yeah, typically speaking, well, there's a perfect indication of a before and after. That to us, we have a lot of emphasis that's put in place at the beginning, at the design stage. Specification engineers will put this forward to a council. It'll be approved. It then goes to the manufacturer to supply the goods. You know, a contractor's on site installing. But several years later, this is what we come across. And that level of neglect is having some serious concerns. So yeah, there's a handful of that exhausted media that we were talking about earlier. I believe that's a commercial development in Adelaide, which is just a standard car park. So it really is interesting to see just how much pollution and what kind of pollutants are being captured on what you would expect to be a relatively clean catchment. And some more suspended solids and floatables that are captured in the storm filter chamber zone there. Now we're moving on to the filter membrane technology. Again, quite a superior technology in the marketplace at the moment. There should be a video that illustrates. Oh, there we've got some brand new filters. There's one of our stars there, Lily, installing some brand new filters. We refer to them as tentacles, but that's basically a brand new system being installed and commissioned on site. Water will make its way down through the inlet. Again, the maintenance access wall contains the floatables, the driving head that rushes up through that very fine filter media. Oh, sorry, fine filter membrane. It then kind of bubbles up over that pooling system, and treated water is able to discharge out into the local rivers and creeks. And that's what we're really getting to here. As you can imagine, the smell, the level of hydrocarbons, the oils that are being captured. It's a really interesting field to be in. I think I've been involved with it for over 10 years now. Nothing's really changed. We constantly see these. Now, keep in mind, in this particular application, it's quite a heavy industrial facility, a lot of traffic movement. You know, you have to consider that they may not necessarily all look like this, but we are giving you some of the worst case scenarios. Again, you can see that oil sheen over the top. So, you know, what are we doing flushing down contaminants into our stormwater systems to begin with? This is things that local government authorities can explore further. But yeah, in general, I just think that we need to move towards a proactive setup rather than this reactive. Speaking to a lot of asset owners, property managers, developers who are leasing their developments, it's several years down the track before they realize that you know, they're in trouble and they need to spend some big bucks on getting these systems back up to a compliance status, or getting their water quality objectives back up to where it was initially during the design stage. With ongoing monitoring from the very beginning, we could drive those costs down and ensure that the systems continue to work as they were originally designed to. So thanks very much for your time. I'll pass it back over to Daniel.
Yep, no, thanks for that. We're kind of near the end of the presentation before we get into Q&A, so I might just do some take-home messages and then we can get into Q&A. But basically just a few things I wanted to highlight is that stormwater can be a valuable resource. It can be very polluted, it can be poorly managed, but if it was managed properly, it was being treated, it provides communities across Australia and the world really an opportunity to have a valuable source of water as climate change happens, as droughts happen, and as cities want to move towards becoming water sensitive. It provides us an opportunity to have a valuable resource that we can use, but it does require maintenance and treatment for that resource to be available. I'd also just like to highlight that stormwater can be and typically is high in pollution. This photo shows it. It can be a lot of different types of pollutants in there. They can be very large, they can be very small, they can be even hidden things such as microplastics and more things like hydrocarbons and all of that. So it can be very different, but it is very high in pollutants. And I hope today's webinar can really show how polluted stormwater can be. In terms of treatment assets, like the ones we've talked about today, they need to be resilient for incoming variable loads. As I mentioned earlier on, they need to be prepared to capture pollutants that are happening now, but also be prepared for the changes in the future, whether that's the change in rainfall, but also the types of pollutants. When there's legislation and bans put in place on plastic bottles, maybe there'll be something else that becomes more present in these sorts of assets, or removing plastic straws a few years ago in New South Wales would lead to them disappearing. Or if there's another pandemic at some point, then there'll be more masks, and those sorts of things can happen. So these assets need to be prepared for today, but also the future. And they also do need to be maintained. It's great to see these photos where they're filled with pollution. However, that pollution's not being removed. It's going to bypass that system and enter into the waterways and environment and have a range of different impacts on the communities, environment, waterways, wildlife, and the oceans. And this is where maintenance compliance is essential. Fotos touched on councils and stuff stepping up a bit in this space, and that's kind of where maintenance compliance falls into play, where councils like Blackdown Council are leading in this space, showing councils how they can do this, and other councils are starting to really step up in this space and try to do something with this. And to help those councils, a project I've been leading for over a year now at Ocean Protect is the WSID Maintenance Compliance Framework, which can be accessed, and more info is found via that QR code. But basically, it's a free package of information, resources, and tools that councils can use to improve the implementation and management of WSID assets within their jurisdiction. There's a guideline, there's process maps, there's a mock-up technological system, and a whole bunch of other things, such as content for fact sheets and letters. And it's really providing councils a lot of stuff that they can use in a way that works for them. They can modify this, play around with it to suit them. And if you're wanting to learn a bit more about this, I'd be happy to sit down with people and have a meeting. I also want to highlight it's not just Ocean Protect doing this. There's several organisations that have provided principal support, such as Stormwater New South Wales, Stormwater Queensland, Optimal Stormwater, and a few others. And then this has just gone through a consultation period, a 4-month consultation period, which saw over 500 people getting involved. So a lot of people have had the chance to really get involved and provide their input for this. And so that is the end of the presentation. And before we get into Q&A, just reminders, if you do have questions, if you can put them in the Q&A panel, that just makes it easier for us. If you're looking for the slides and recordings, those will be up as soon as we can on our website. And if you're looking to get CPD forms, please send that request via email to inquiries@oceanprotect.com.au. And again, this session was part of the Stormwater Fundamental series. We just finished the 9th one, with upcoming ones being for development assessment, WSID asset maintenance, which Fotos and I will be doing, and then one in November, which I'll be doing about WSID asset compliance. More information about all of this can be found on our webinars webpage. And that is the end of the presentation. I'll thank you all for coming along. Our emails are on the screen if you want to get in contact with us, and the phone number in the top left-hand corner. And I might hand it over to Brad to facilitate Q&A for us.
Cool. Thank you, Daniel. Thank you, Fotos. Thank you, gentlemen, for a wonderful presentation. Super popular session. I can see over 200 attendees. So thank you, everyone, for dialing in and giving up your time to let Daniel and Fotos show what we see down our assets. For me, the take-home message is, yeah, stormwater is full of a lot of pollution. I think I spent 15 years in consultancy for Ocean Protect, and I think it's easy to sit behind your modelling software, whatever it might be, and just assume that stormwater is actually relatively clean. Might have some nutrients and solids which you need to remove, but when you look down some of our devices and others, you can see that stormwater is full of pollution. That's the other thing I wanted to raise was this is only what we can see. You know, Daniel showed there's a whole bunch of sediment just getting caught in, say, gully baskets and membrane filter, but so it's easy to see the litter, easy to see the dirt, but what we don't understand, and we're getting a better understanding of, is just what the pollution that we can't see, the microplastics, the heavy metals, the PFAS, etc. And so we're collaborating with a few different groups to get a better understanding of what we're finding. But you can tell from the analysis we've done so far that the pollution we're capturing is full of those pollutants that you just physically can't see. But also, I think it's a fool's game to think that a vegetated asset, whatever it might be, whether it's wetland and bioretention, is sufficient to just remove this pollution as a standalone technology for all sites. Maybe some sites, and maybe your music model might show that your bioretention can remove 100% of gross pollutants. But as per the images, particularly that Fotos showed of the jellyfish, that stuff will kill any vegetated asset. So at the very least, I think if you're going to use vegetated systems, I'd really recommend pre-treatment for a lot of land use types. But I can see the question is coming through already, and I'm just going to first in, best dressed. So question number 1 from Jeff Ravage. Jeff asks, regarding used filters containing petroleum hydrocarbons and other contaminants, has there been any issues with landfill operators receiving these types of contaminated wastes? Has there been any requirement for analytical testing, such as total and leaching TCLP? Might be a question for Fotos. Any dramas associated with taking the removed pollution or the cartridges to landfill?
I think it's definitely, in the past, we've had situations where the actual pollutants that have been contained or captured have not fallen within a standard stormwater runoff waste, and therefore that waste classification or category kind of falls into kind of more hazardous material. And the implication of that is the disposal fees are much higher or need to be treated in a different way. And so I think the issue there is that ongoing maintenance costs, unless the asset owner, has the appropriate measures in place, that cost will then be absorbed by the client. So we have seen it from the disposal facilities perspective. I think there would be some tipping facilities that are EPA licensed to take that waste, whereas some wouldn't. So that's how I'd address that one.
I would also just add something that Ocean Protect are looking at the moment is working with UNSW to look at kind of maybe the potential opportunities to recycle the kind of jellyfish tentacles but that's still kind of very early stages and something we haven't looked into too much, but we're hoping we can find something that can kind of help do that so less of this stuff is going to landfill.
Cool. Question from Mihao from Melbourne, and you're going to have to try to have a guess at this answer. Mihao asks, do you have any idea what's the percentage of WUSIT assets that are regularly maintained? And if you have an answer, why do you think that is? So what Daniel first, what proportion of WUSIT assets do you think, of all the ones that are put in the ground in Australia, what proportion do you think are maintained?
I think very little are being maintained. A lot of them are being installed and then kind of just set and forget mentality with these assets. The numbers that I hear a lot about is kind of 5 to 10%. There was a study done by the Parramatta River Catchment Group in Sydney a few years ago, which found that according to the asset owners, about 20% of assets were being maintained. So look, it's very kind of low numbers. 20% was a lot higher than I'm used to hearing, but I think that's really happening because councils are struggling in this space. That's kind of what I'm hoping to help, and there's other people and organizations in the industry looking to try provide resources and help the councils to deal with this, because councils have so much to do and it is their responsibility to enforce compliance on private assets. And with councils having so much to do, that can be a struggle to do. And then internal public assets as well can be hard to manage because it requires all the budgeting, capacity, staffing, and resources in place to do that. And so that is, I think, something councils are really interested in solving at the moment and something I'm looking to kind of address. But maybe Fotos might have a bit more of a number based off his experience.
Have a guess?
Look, I think if councils are fortunate enough to have their own compliance officers that conduct this auditing internally on both private and public assets, I think my gut feel would probably be that there's around about the 20% mark of systems. But even in situations where they don't have that resource internally, there's still the opportunity to engage private consultant to do this work on their behalf. And what's really concerning is that if only 20% of these assets are being maintained, and it's a legal requirement to have these systems, as per the EPA Act, then what's happening to the remaining 80%? That's probably my main concern. But yeah, I'd be a bit more optimistic and say 20%.
Yeah, I think if I can answer, I reckon it varies. If you want to have a blanket rule across Australia, I think it's probably 10% maybe. I think if we're lucky, which is pretty abysmal. You know, if we had a fleet of cars purchased by state and local government across Australia, and we only looked after 10% of them, and 90% of them were, you know, conked out on the side of the road, we'd be horrified. I think it's like, if I give you an example, some councils do a good job. So I think Gold Coast Council, for example, to the best of my knowledge, are actively maintaining the majority, if not close to all of their public-owned WSID assets. Obviously, Ocean Protect, we install assets, and obviously we've got guys like Fotos really trying to push property owners to get those assets maintained. So I think Ocean Protect assets, I think you might know the number off the top of your head, Fotos, but I think the proportion of Ocean Protect assets that are appropriately maintained regularly is actually quite high.
Mm-hmm.
Is it 100%? No, but we're sort of trying to improve that every day. Mainly thanks to, I think, Fotos is leading the charge on that. And I think the second part of that question was, why do you think that is? I think a big part of it is probably two things. Number one, most of our assets are out of sight and subsequently out of mind. But the second part of that answer is also our regulators are doing nothing to enforce existing legislation to ensure the appropriate assets, to ensure the appropriate maintenance of these assets. As Daniel has talked to previously, it is illegal to not maintain your stormwater treatment assets, but it needs councils and other regulators to appropriately enforce that legislation. Now, if I had a septic tank in my backyard and the back end of Bendigo, and if I didn't look after it, I can expect a knock on the door from my local council, and deservingly so. And that asset's underground, out of sight, out of mind. I think it shouldn't be any different to stormwater treatment assets. We know they're a major source of pollution. We know 80% of all ocean plastic comes from our stormwater systems, etc. We know it's a massive issue, but we're just not doing anything about it, probably for those two reasons. Anyway, we'll move on to the next question. Might be one for Fotos, sorry. A question from Daniela Garenti. They ask, how do you get rid of the waste produced, and how much does it cost?
Yeah, that's a good question. So typically speaking, a confined space qualified team will attend site. In a lot of these cases, you might have a relatively large filtration chamber that needs to be cleaned out using some sort of vac truck or a power washer to bring that system back. Usually that waste is transported to a waste facility and then disposed of. These tipping facilities have weigh bridges so that you'd know the amount of waste that was disposed of, and you'd have receipts and service reports would be generated from that. You'd also be able to get some estimates of that pollutant breakup, be it the sediment, the litter, the other things that we mentioned. And in terms of costings, I think it would vary in terms of what's required, but I think a standard rate would be a couple $100 per ton of stormwater waste. Keeping in mind that the density of stormwater waste is higher than water. So it wouldn't just be, 1,000 liters rate, it would be more by the ton. But yeah, a couple $100 would sound right in Sydney, New South Wales. In comparison to other states, it's probably a bit cheaper. It all depends on the facility that you go to.
Sure. Everything's cheaper outside of Sydney, isn't it, gentlemen? Hey, question from Keith Watson, might be one for Fotos. Keith asks, have you noticed any reduction in the number of bottles being captured since the introduction of the 10-cent refund on bottles in Victoria? I think you've seen that in New South Wales as well, by memory.
Yeah, I think so.
What have you seen, Fotos?
I think cans and bottles, yeah. It goes back to the principles of incentivizing people that do the right thing, isn't it? If you take away, if you give someone the opportunity to do the right thing, and they can get paid for it, there's going to be a different effect to, say, a council officer going out there and issuing fines on someone who's doing the wrong thing. That's probably not going to contribute to the long-term goal, which is to get these systems maintained. So capturing it from the start and bringing in programs like that, it definitely have an effect. We see the vapes and down there as well as the cigarette butts now, though. So there is like a contrast. So certain things are brought in. Different measures have different effects. definitely on the assets.
Yeah, it's interesting. Like, if I can make two comments. So there's a CSIRO study that was showed that where container deposit schemes are in place, they see I think it's a 20 or 40% reduction in bottle littering and other littering as well. I'm actually currently at a litter congress in Sydney, and they've actually just been talking about what are they finding. And one of the comments from the head of the New South Wales EPA litter program, John Laverack, he said, cigarette butts are back. I didn't think they ever went away, but with obviously vapes, they saw less, I guess, cigarette butts, and now obviously it's harder to vape. They're basically seeing an increase, basically return to normal levels of cigarette butts. So yeah, to Fotos' sentiments, yeah, it's good to have that source reduction strategies. But gee whiz, I'm always amazed that people still smoke and, do that sort of stuff anyway. But maybe I'm just too clean living, too vegan straight edge. What do you think, gentlemen? Question from Vince Wong. And it might be a question for Daniel, actually. Vince asks, what steps are currently being undertaken to ensure councils and stakeholders are maintaining their assets?
At the moment, not a lot is happening to make sure that these assets are being maintained. This is something that I'm hoping the project I'm leading at the moment with the WSID Maintenance Compliance Framework can address. That is a bit more focused on private asset maintenance, making sure that those assets are maintained. However, there are elements of that would be helpful for public assets as well. So that is something I'm trying to kind of push and get councils on board with and implementing. However, really at the moment, there's no real push from anyone above councils making this a mandatory thing, despite what legislation and policies are in place. Not much is being done otherwise that I'm aware of.
Yeah, there's not enough. Daniel's certainly pulling his weight and driving the WSID compliance program, but certainly there's more opportunity to do more in this space for sure. Question from, might be one for Fotos, a question from Saranda Sar. I think they're asking, can you install or can we install GPTs into existing concrete pits? I think they're talking about the gully pit baskets, Fotos. Can that be done? Can you take an existing gully pit and put in a ocean guard gully pit basket?
Yeah. The short answer is yes. I think in applications where there are water quality requirements that are governed by a local government and they're implemented strategies from the beginning, they're obviously part of the design. But in situations where you've got a site, it's established, it's in operation, you're looking to upgrade your level of treatment on site, you can definitely implement these stormwater gully pit baskets to at least capture anything up to 200 microns. So it's a very fine filter material. So it would definitely be worth monitoring whether that's something you want to do on a trial basis and choose the dirtiest part of your catchment. And depending on those results that you get, you can then look at extrapolating that out to the remaining pits or the remaining depots that you might have. And that's something that we've done in the past.
Cool. I might chime in with a comment just on the back of talk around council activities and are they being maintained. Jeff Babbage, I think, is from Moreton Bay Council. Thanks for these comments, Jeff. Jeff sort of said, and I'll read it out. Jeff says, at City of Moreton Bay, public WSID assets are uniquely numbered in an asset register, mapped in a GIS system and asset maintenance system. They're actively maintained with contractors, generally monthly. Condition assessments are scheduled 3 yearly. Condition assessments have been invaluable in rectification of civil and environmental components of assets. Hasn't always been the case historically, but with an inspection and maintenance framework, corporate policy, resources and funding, WSID assets can be maintained. You cannot comment on the maintenance of private assets though. So that might be the next, that's great to hear, Jeff. That's really good feedback. I was probably working with Moreton Bay back in the day when that wasn't the case, but that's so good to hear because that's a significant improvement and obviously it goes a long way to help protect Moreton Bay. But if you're looking to improve this council's activities in the private WSID space, I reckon you better reach out to Daniel Ryder and he can tell you how Moreton Bay Council can improve their activities in that space. So thanks for those comments, though, Jeff. There's a question on, I'll go back to the start, sorry. A question from Shone Sabu. They ask, with regards to maintenance, this might be a question for Fotos. With regards to maintenance, say we've got 20 cartridges inside an OSD tank. How is the maintenance carried out? Does it have to be replaced every couple of years? How is it removed and replaced? Does it require confined space entry?
Yeah, yeah. I think in terms of the replacement frequency, it's going to come down to catchment conditions, right? So different sites have different level of pollution accumulation, and that would be subject to the rainfall patterns or the site area, percentage impervious, all these different characteristics that make up how dirty your site is. So in terms of frequency, typically speaking, anywhere between 2 to 5 years is probably where those filter cartridges are going to require replacement. The advantage of them is that they're fully recyclable housing components. So we have depots across Australia where we pre-manufacture these filters. They're brought out to site on the day that the maintenance crews conduct that cleaning activity, and the replacement can occur. The old housing components can be brought back to the warehouse and refurbished for the next maintenance job. So we're almost trying to create this circular economy. Yeah, costings for a 20 cartridge system, I think, if you could look at it over over a 10-year cycle, and you had to replace these filters every 5 years, you could incorporate the cost of that filter replacement on an annual fee basis, and you could do some sort of 6-monthly or 12-monthly inspections that would suit. So yeah, it's all about trying to bring those costs down for the end user, because ultimately, whether or not they've budgeted for this, whether they even know that a stormwater filtration system exists on their site to begin with, right? Like, that's some of the situations that we've been in. To give you an example, if the sediment and erosion control measures aren't there, or there's one bad day on a construction site, I can tell you right now that 20 cartridge system wasn't functioning from day one. What do you do in that scenario? So it's all about this low fee, high inspection frequency programs that we offer to avoid any potential issues in the coming years.
There was one more element to that question. Do you need a confined space entry? Yeah, look, you do. You need to physically, or someone needs to get down into the OSD tank. It's very easy to remove the cartridge. You literally click it to do a turn, and the cart can be removed quite easily, but someone does need to get down there physically. Am I right in saying that, Fotos?
Yeah, and there'd be safety procedures that you'd follow to be able to enter that. There'd be some sort of gas meter that would detect certain atmospheres to ensure that it's safe to enter. There's some sort of tripod or harness to allow an individual to be lowered down, depending on how deep the system is. But yeah, there are the measures in place to conduct those works safely.
And there was just a follow-up question from Daniela Garenti around costs, and she just wanted to clarify with you, Fotos, if the waste that's removed and taken to wherever, is it always considered as contaminated, and as such, does it incur a higher cost to landfill, or does it need to go to special landfills? Like, so long story short, do you assume it's really contaminated and needs to go to a special landfill, or do you do testing and determine whether it's safe, or?
I think in the situation where you've found oils or contaminated waste, then definitely I think you'd have to go down the path of having it disposed of appropriately, which would be classified as hazardous waste material. But typically speaking, the majority of systems that we maintain are classified as stormwater runoff material. And as a result, you can have these waste disposed of at the approved tipping facility. I think in New South Wales, we have the luxury of disposing this waste at certain facilities that have the option of having this. I think it's something like 90% of this material can be recycled and used and brought back into agricultural industries and stuff, and used as fertilizer. So there's some really good stuff and cutting edge technology out there that's allows us to then, create this circular economy.
Cool. Thanks, Fotos. Might be a question for Daniel. See if we've been talking about this for a little while. A question from Mohammed Sowad Chowdhury. That's an awesome name. Mohammed asks, for bigger catchments where we can accommodate a biobasin for pollution reduction, is it always recommended to place a GPT upstream of the bioretention system? What do you think, Daniel?
Yeah, so I would say yes, it would be good to have a GPT upstream of a bioretention because that can remove those big pollutants while that bioretention can focus on the more smaller insoluble things like chemicals and all of that. And Brad and I were recently out up in Queensland looking around at a bioretention which didn't have a GPT upstream and it was just filled with pollution. And we tried picking up some of it ourselves, but there's just so much if it's not being protected upstream. So I'd say yes, and I do think that Brad can probably comment on this, but in a recent podcast episode with Murray Powell, there was talk about needing GPTs upstream of a bioretention.
Yeah, to quote, it was actually wetlands. I think to
Oh,
quote
okay,
Murray, if you're putting in a wetland and don't put a GPT in, you're crazy. But yeah, look, I know in our music modelling guidelines, at least in Queensland, there's a throwaway line that anthropogenic litter loads are quite low from urban areas, and it's just not. I can tell you right now, it is not true. It's a lot easier to remove litter and other pollutants from a GPT upstream of a bioretention system than it is to try and walk through a bioretention system or a wetland, whatever it might be, and try and pick it out by hand. I think it should be the standard. If you're putting in a large end-of-line bioretention and wetland, I agree with Murray. You really should have some sort of pre-treatment. Now, full disclosure, conflict of interest, of course. We sell GPTs. You don't have to buy them from Ocean Protect, whatever. And if it's not a GPT, it should be something that can at least go a long way to removing litter and coarse sediment loads. That's my 2 cents. So that's what I recommend, Mohammed. Take that advice however you see fit. There's still a heap of questions coming through. Apologies, I'm not getting to them all. A question from Shin Lee. I think it might be for you, Fotos. Do GPTs like the Ocean Guard and the Ocean Save, do they have a fail-safe? I.e., if the maintenance crew can't get there after a storm and the GPT is full of pollution, is it still operational? Or at least do the pollutants that are retained not cause blockage or backup or flooding?
Yeah, I think there will always be a risk of potential flooding. But with that being said, in the majority of cases, and comes back to the design engineers, there will be some form of high flow bypass implemented into the stormwater treatment infrastructure. So whether that be the system being offline and having some sort of diversion weir that would allow, even if the GPT or Ocean Guard was completely full of pollution, the system would just go into bypass, which has a negative impact on the water quality aspect, obviously, because all the untreated water is now discharging into the council mains or local rivers. And that's probably the case in a lot of neglected treatment assets. They just reached full capacity, so they've achieved as much capturing as it can, and basically sit in bypass for the remaining portion of their life.
Yeah, thanks, Fotos. Another question might be for you as well, from Gordon Wolf. What is your recommended maintenance schedule for a installed gross pollutant trap by Ocean Protect for residential discharge into Sydney Harbour? And does it need to be done by certified personnel?
You definitely want to have experienced maintenance personnel engage in this monitoring activity. And the reason being is you want to have credible information that you can rely on to establish your ongoing maintenance program. So I think those first couple of years is probably a fundamental time to establish the frequencies and how often your GPT needs to be maintained, depending on your catchment characteristics. So I'd say probably a bit more frequent at the beginning stages, maybe every 6 months. But once you have a gauge of how often that actually needs to be serviced, you can then extend that out to an annual inspection. But typically speaking, every 6 to 12 months is the current recommended inspection frequency that we offer. And within that, some of the details that we would offer would probably be how much sediment has accumulated in the sump zone of that GPT. And then that kind of gives you an indication of how fast it's building up so that you can put in place an appropriate maintenance program.
The other aspect of that question was around certification, and you talked about you should have, should be done by suitably qualified personnel. I think, to the best of my knowledge, there isn't a certification scheme for maintaining stormwater treatment assets. Obviously, Stormwater New South Wales have their maintenance guidelines for assets, which was authored by Murray, and he does the training, and you can get a certificate to it that you've attended, whatever. But I think, correct me if I'm wrong, gentlemen, there's no certification scheme as yet.
No certification, but something I want to work towards in the coming years, hopefully.
Cool, awesome. Might be what a question. There's a question from Shin Lee. It might be best if maybe Fotos, maybe. Shin Lee asks, gully pin inserts in roadside curb inlets is a health and safety concern for maintenance crew working near live traffic to inspect and empty. Council removed them after a subdivision was handed over. Are there guidelines for designers of where they can be installed?
Yeah, I think this is probably not our area of expertise, but traffic management systems can be, traffic management plans can be incorporated into the overall maintenance program so that an external specialist can come in and provide that traffic control while stormwater maintenance personnel are in public road settings and conducting this cleaning. It's also part of the safe work method statement that we adopt is to have, clear from any vehicular access and kind of cordon that area off, create a safe working environment. So it is a tricky one. It probably does incur additional factors or costings that need to be associated with that upkeep, but it is doable. It's definitely site specific though.
Yeah, site specific, but also probably council specific. I think there isn't, to the best of my knowledge, and please put it in the chat if you can know of a industry accredited guideline around, where to put gully pit baskets. But I think it's often up to the local council to determine whether they allow their use in particularly public roads. Private sites, it's generally okay. Recognising Fotos' the items that he's raised now, but yeah, I think if in doubt, check with council. There's no point putting them in, just have them ripped out afterwards. Question from Reza Atashi. Reza asks, for maintenance, what guide do you use, or is there any software for regular maintenance? In other words, what strategies do you suggest for asset management?
Oh, I think the education is there and the resources are there. And Daniel's probably done a really good job of creating those resources. So all the leading councils would obviously have their maintenance guidelines available online. And we'll probably be able to post a few of those links in this chat if you think it's appropriate to lead people to the documentation.
I think for this, I guess the guides out there, the manufacturers like Ocean Protect do have guides for our devices. Then there are councils like Blacktown City Council who have their own guidelines, which councils can get a copy of and modify to their needs in accordance with a Creative Commons license. So that exists, but there's also the Stormwater New South Wales guidelines, and there are a whole bunch of other guidelines in the industry. So it really depends on what the councils are wanting and what they want to do in this space. So that can kind of really help with the asset management. It just really depends on what type of assets you're talking about, as some documents won't cover everything.
And in terms of digital software, we as a maintenance contractor would have our own software that we would be able to generate service reports and documentation outlining the specific cleaning visit that we've conducted, so that can all be kind of automatically populated. But I'm sure there would be asset management software out there that exists that's specific for stormwater treatment systems.
Question from Shane Dave, and unless you guys want to answer, I can give it a try and respond. Shane Dave asks, and I think I've interpreted this question right. Can a GPT replace the need for a conventional bioretention basin, or is a bioretention still required? Basically, a lot of these devices get put in to achieve local pollutant load reduction targets. Generally, something like an 80% reduction in solids, 45% removal of nitrogen, 60% often removal of average annual loads for phosphorus. To achieve those, you generally need a treatment train, a combination of assets. So whether it's a GPT and a bioretention or a gully pit basket and some cartridges, etc., to basically have a whole bunch of treatment processes, physical, chemical, often biological, to help remove pollution. I do see the occasional claim that a single GPT can do all those things and achieve an equivalent environmental outcome in terms of pollution load reduction targets. If you see a GPT manufacturer saying that they can basically, by putting in a single GPT, you can achieve those pollutant load reduction targets, I would suspect, I would do one thing. I just ask for proof. Proof that you can, proof that their asset achieves those those performances, and ask that proof in a format that you can provide it to others for review, such as people like me. But fundamentally, Ocean Protect, we probably sell one of the best, if not the best, GPT on the market. And from the bottom of my big heart, I can tell you right now that a single GPT will not be sufficient to achieve the standard average annual load pollutant load reduction targets. So that's probably my 2 cents on that matter. Any other comments from Fotos and Daniel?
No, I think.
No.
Oh, Fotos, you go.
In general, GPTs would have a screening mechanism that would contain about a 5mm aperture penetration. So, anything smaller than 5 mils in size would potentially make its way downstream and bypass treatment. So I don't see how a GPT can be a superior technology and take on all the efficiencies of, say, a filtration system.
Yeah, I think for me, I just want to add, I think that shouldn't really depending on the context of the site, just having a single asset won't always work. You need multiple assets working together to form a system, kind of a treatment train where you have primary, secondary, and tertiary treatment that are removing different pollutants, because, yeah, a single device can't do everything.
Question from Mihao. Mihao asks, the modeling currently done. The modeling currently is done with TSS, TP, and TN. Do you have some data on how these relate to heavy metals and tire dust? I.e., can you say anything about heavy metal reductions in the context of the device performance? I can comment on that, but happy for you guys have a crack at answering that.
Go for it.
Fotos?
I
yeah,
think
cool.
the total hydrocarbons is also a factor that could be modeled. But yeah, by all means, Brad, jump in.
Yeah, look, Fotos mentions hydrocarbon. Let's talk about that first. So we often get asked to comment on, compliance with hydrocarbon targets, and the advice I give, and it's all based on reference material and published peer-reviewed journals and all that sort of stuff, is the vast majority of hydrocarbons, in particular, are attached to sediment. So if you can remove sediment, you go a long way to reducing hydrocarbon concentrations. Very similar to, say, heavy metals. The majority of your heavy metal concentrations in stormwater will often be particulate bound. And if you remove particulates, which we generally do with whatever devices we're looking to put in, or a combination of devices, you'll go a long way to removing heavy metal concentrations as well. Furthermore to that, we've got the heavy metal removal rates for a lot of our assets. So I know for Storm Filter, for example, which is probably our flagship product, we've put in 30,000 plus across Australia. We've got a lot of data to show that they essentially are very effective at removing heavy metals and hydrocarbons and oils. So hopefully that answers your question. It is hard to model these, obviously, because there's a lack of industry standard pollutant export characteristics for hydrocarbons and heavy metals. But I still maintain, if you can remove your sediment loads, your suspended solids, which obviously is modeled in music, you'll go a long way to substantially reducing your concentrations of other pollutants. So hopefully that answers your question. Question from Sam Budden. Sam asks, any advice on modifying GPTs and or drainage systems that are being affected by sand washing up the system from? Oh, that's a doozy. Anyone want to comment on that one? Photos?
Um, look, I think if the it's more than likely a marine environment, if that's
Yeah,
the case from sand, and so as a result, I think you want to ensure that the internal components of that GPT are sufficient to cater for that marine environment, be it in a high salt content of water, potentially backing upstream. But yeah, that's an interesting one. I don't have the
yeah.
answer.
For me, it comes back to site selection. Uh, you know, there's always constraints with putting in a device at a particular location or locations, and an appropriate site evaluation should be done before looking to install the asset, as opposed to trying to fix up a device that just probably should never have been put there in the first place. So, a classic example would be our gel cartridge, which Daniel and Fotos talked to before. We're very conscious of making sure the tailwater levels from marine environments don't come and back up into the jellyfish tentacles and potentially foul the tentacles. So same principle should be applied for GPTs and other devices. I know Murray Powell's number one rule of GPTs is just don't cause flooding. So I think if your device is getting full of sand, I think you might have failed Murray's test number one. But cool. I think we've had a lot of questions. I know a couple of them have come through the chat, so let me just have a quick look at.
There is a one
yeah.
about microplastics.
You want to have a read that out, Daniel, and try and
Yeah,
answer?
so Reza Tashi has said, for microplastic treatment, did you test any samples and what type of asset is best for microplastic treatment, or what strategy you will follow? Brad, do you want to comment on that about UNSW stuff, or?
Oh, yeah, you can do that, Daniel.
Yeah, so we have started doing some work with UNSW looking at microplastics in stormwater. It is, again, very early stages with them, so we don't have a lot we can probably say in this space, but it did find a lot of microplastics, very hard for people to see from the eye, but using the technology and processes that they had, they're able to find quite a bit in the samples that they took from some devices. So yeah, we're kind of following their procedure and everything, but that's, yeah, hasn't really been put in place yet, but that's the best I can kind of say at the moment.
Yeah, look, and I can comment further on terms of removing microplastics. Yeah, generally, if you can remove dirt, you go a long way to removing microplastics. I know there's been a study of bioretention systems that showed like 90% removal of microplastics, which you'd expect given it's got to flow through filter media. Very similar for cartridges and membrane filtration. One of the big dramas with microplastic is currently, I know this is going to be changed, there is no standard procedure to analyze microplastics in water samples. That will be changed. I know the guys in the States, the EWRI committee are working on a standard, which will hopefully become more widespread. But yeah, again, if you can remove fine particles, you go a long way to removing microplastics as well. We might have one final question that just come in right at the end. Shane asks, using GPTs prior to OSD is very common nowadays. What happens to the sediment that enters the OSD? So is it necessary to use cartridges inside the OSD? If so, how do you make use of the plastic OSDs? I'm not sure if Fotos, do you want to have a crack at answering that, or I can try and have a go?
If GPTs are located upstream of the on-site detention tank, it doesn't necessarily mean that there's a filter cartridges installed in the OSD. But if sediment made its way in there during the time of inspecting the GPT, you'd also be looking at inspecting that downstream infrastructure, be it the OSD or whether cartridges are installed or not. So I think you'd be able to gauge how well your GPT is performing based on the amount of sediment that's accumulated downstream. And then you could put in place some sort of appropriate cleaning frequencies to cater for that.
Cool. Thank you, Photos. We're bang on an hour. Well done, gentlemen. You've kept to time. If you got any further questions you'd like to ask Photos, Daniel, and myself, feel free to reach out via the email addresses. Also, just a reminder, if you want a CPD form, I know Daniel will have the email address there. It's the inquiries@oceanprotect.com.au. But we look forward to seeing you guys at the next webinar. But again, if you've got any further questions, just feel free to reach out. These guys love talking about stormwater pollution. we'll hopefully see you
Appreciate it.
guys soon.
Thank you,
Thank
Brad.
you very much,
Thanks,
Daniel and
everyone.
Fotos, for giving up your time today. Much appreciated.
Thanks.
Thanks, everyone.